Hello, everyone, and welcome to my session on unleashing excellent data ops with LinkedIn DataHub. The tagline is, your data is not changing slowly, so why should your metadata? I'm Shirshanka Das. I'm co-founder and CTO at Acryl Data. We're a startup that's partnering with LinkedIn and the broader open source community to take the LinkedIn DataHub and Apache Goblin projects forward. Prior to this, I spent a decade working on data infrastructure and platforms at LinkedIn, where I founded these projects. So I was actually organizing a metadata day event 2 months ago. And what we realized was, the more we talked about metadata, the more we came back and talked about metadata, data itself. So to talk about metadata, you first need to talk about data. So what's happening with data? Well, quite a bit, actually. If you look at the global trends in the data ecosystem right now, enterprises are really rushing to unlock insights from data, and that means being data-driven, using data and harnessing the power of it. And also, at the same time, there's a huge rush to also move to the cloud. And meanwhile, we are moving from the past decade of going from a monolithic, single system style enterprise to a fragmented, lots of different tools to solve this data problem. But at the same time, kind of categorizing these tools into segments. And we're finding that the data ecosystem is coalescing around a few terms: data ingestion, data transformation, data visualization, operational stores, streaming stores, data warehouses, data lakes. We now know what these terms mean. And there are several tools or technologies in each of these segments that are attempting to solve these problems well. A good case study is actually LinkedIn. If you look at LinkedIn's data ecosystem, at the very top, you've got our members, customers who are accessing the website using desktop or mobile apps. And internally, we have our employees who are using internal apps, dashboarding tools, data portal style tools, reporting tools. And all of this experiences are built on top of somewhat homogeneous in terms of how it's built stack. We've got services. These are our microservices that are built using Java mostly and some in Python that are essentially creating data. And that data flows into operational databases. I built one called Espresso. It's a distributed database, but we have MySQL. We also have a little bit of Oracle, I think. And all of that data comes back out as change streams, which go into Kafka and Hadoop, as well as incremental dumps that are coming out from these databases periodically or nightly. And it goes into this combined data warehouse of a streaming platform built on Kafka and a batch platform built on Hadoop. And inside this platform, right, magic happens. These data sets come in, they are then transformed into more interesting data sets. These could be features, models, insights, metrics. And all of these derived data sets get loaded back into serving systems that are, again, specialized for the kind of needs that the services have. So we've got search indexes, graph indexes, OLAP indexes, sometimes optimized key value stores to serve these kind of requests. And finally, you've got the services back on top that are now able to read these derived insights or derived data sets and produce them back into the front-end experience to give you that kind of seamless, snappy experience that you've come to expect, where you're able to comment on things. And then very soon you're able to see insights about people who've commented on this have also commented on this other thing, right? So this is what a complicated, complex, big company like LinkedIn's ecosystem looks like. But if you look at smaller data ecosystems, companies that are just starting out, they have something like this too, a smaller subset maybe, but they have microservices, they have operational data stores, they have streaming systems, they have a data lake, and they have derived data sets that they're creating that are then getting merged back into the online service. So this kind of complexity is everywhere, and it's leading to a lot of pain points. These pain points are being faced by humans as well as software. When people come to do some analysis on the data set, data ecosystem, they ask, hey, which is the authoritative customer data set? Or what are all the dashboards that are powered by the customer data set? Maybe I'm a workflow and I'm about to start and I want to ask a question whether the customer data set is ready to be consumed or to be processed. Are we sharing customer data with third parties? Do salespeople have access to customer data? Did they ever have access to it? These are a lot of different questions that humans ask about data sets, and software or programs also ask about data sets. And these are hard problems to answer when you have such a diverse ecosystem of different tools and different systems where data lives. So quick pop quiz, right? What kind of questions are these? Are these data discovery questions? Are they data governance questions? Or are they data ops questions? The answer, of course, is that they're all of the above. The questions look kind of similar, but they're actually coming from different personas, different intents. But you still want to solve all of them. And the real question is, can you? So we built LinkedIn DataHub to solve these problems. It's an open source project. We're hosted at datahubproject.io, and we have a growing Slack community where we talk about all things data, data discovery, data management, data governance. So it's been an amazing journey. It of course came out of LinkedIn, but in a very short amount of time, we've gotten a lot of partners who are working with this project and have deployed it in production, and a lot of companies that are actually doing POCs and about to deploy it in production. So we've got a very vibrant community. We've got almost 3,000 GitHub stars, fingers crossed on that one, and getting up to almost 100 contributors that are committing code back. We've got a pretty healthy commit activity. So we're really excited about how this project is shaping up. It's one of the leading open source data discovery projects. And we highly recommend you check it out. And today I'll talk about some of the things in terms of how it's built and where it's going. So I talked about three things, right? Data discovery, data governance, and data ops. And the question I'd like to pose to you is, how do you kill three birds with one stone? So let's come back to that original picture. You've got all these different segments and different tools within these segments. And if you look a little bit deeper, you can see that there's something that's common across all of these. And that's actually the metadata that's at the core of each of these systems that makes them unique in how they work. A data ingestion system has some metadata inside it, like a data set that it is ingesting, some schedule that tells it when to ingest it, maybe some transformation logic that tells it how to transform the data before landing it, and metadata about what that ingestion looked like, how many records were ingested, and so on and so forth. There's like little bits of metadata inside each of these individual systems. So if you ask this question, like, what is metadata? What kinds of metadata are we interested in? That's a very deep question, and people have pondered upon it for years and years. We can start with the data set, which is the simplest thing that comes to mind when you think about metadata. You have data sets, and associated with those data sets are elements of metadata that are important, like the name of the data set, because without that, how do you even access the data set? How do you even give it a name to address it? But then if it's a structured data set, you want to know what's the schema of the data set. And if it's a time partition data set, you might want to know more details about how many partitions exist and whether it's a daily data set or an hourly data set. But there's another important thing about a data set. A data set has owners, and those owners are important because they link the data set to people. And people are important because people know about data sets, they consume data sets, they produce data sets, they organize themselves in teams, and they work on data sets together or projects together. And sometimes they create dashboards. Dashboards are important because they contain metrics. They themselves have names, they have charts and metrics, and these metrics characterize where the business is going What are the business KPIs? And metrics themselves have queries on top of data sets. So metrics are related to data sets. And similarly, now in the AI ML infra world, you have models and features, which are also produced by people, but also sitting on top of data sets. So as you can see, there's a huge graph of data constructs and people and code that are all linked together. And the more we can represent about this graph, and the more we understand the dimensionality of this graph, the quicker we can answer questions like the ones I was posing before. So that's kind of the mission, to be able to understand everything about the enterprise metadata graph, to be able to represent it in the best way possible, and then to get insights from it. So the opportunity is, you've got all of these different tools that have little bits of metadata inside of them. How can we liberate and standardize this metadata and then drive innovation that doesn't depend on one specific tool or a particular set of tools? So step one in that journey is liberating metadata. Every time I draw this picture, there's like one more system that has been invented and needs to get connected up to. But that's the reality of life. There'll be a lot of systems that will emerge over the years, and we will need to liberate metadata from them. So we start out with the simplest recipe possible, which is pulling metadata out. DataHub has a very simple Python-based ingestion framework that we recently built. It can be scheduled using Airflow, and it features a very extensible framework to connect up to these source systems and pull metadata out. It's actually inspired by Apache Goblin. Thanks to having done this so many times, it wasn't hard for us to go back and invent a very simple metadata ingestion system that connects up to these source systems and gets metadata out and then emits it out into two different places, depending on what your preference is. It can either write it out to Kafka, and then that stream gets ingested into DataHub automatically, or you can go straight to the service tier using HTTP. And depending on whichever one you want, you either get instant feedback or you just do a fire and forget. And different people like different things. And so we have kind of that configurability. It's pretty simple. You just write your favorite YAML file and configure your source, and off you go. So that's how you start. You start by pulling metadata out of these systems, but that's not where you want to end. You want to actually connect up into these systems and allow them to push metadata out when it changes, because that's the best place for you to actually capture changes that are happening in metadata. So we have emitters, and these emitters are living inside existing workflows. Like, for example, if you have got an Airflow DAG and you're processing some data, you can just inject a little Python emitter to emit metadata out. Maybe this is lineage metadata, where you read a data set and you're producing another data set. And you can just push that out into Kafka. And the same stream that I just described above continues to hold true. You emit metadata out as proposals. Hey, here's a change to metadata I want to happen. And DataHub ingests it and applies it. Or you can go straight over HTTP as well. Same thing with Spark. And interestingly, you can do this with Git as well. So we've got, at LinkedIn, we had this thing where we have all our schemas checked into Git. And in fact, we wanted to have compliance annotations, such as this particular field is a member ID identifier or an email identifier. And we wanted those things to live right next to the schemas and the code. So we actually checked them into Git, and we had built plugins that would actually create these events and then emit them at point of deploy or at point of commit, depending on what part of the cycle you want to connect up to. So you can allow for essentially the same CI/CD style approach to code and data and apply the same thing to metadata as well. So that way your metadata is never out of sync, and it is changing as your website and your service tier is changing, which makes for an extremely fresh metadata graph. So, all right, this is how we liberate metadata. We have pull APIs to pull metadata out, and this kind of bootstraps your system. And you have push APIs to push metadata out from where the changes are happening. And sometimes you do both. And that way you get kind of a vibrant, real-time, always up-to-date metadata graph. But how do you store this metadata? So that's step two. And over here, a lot of projects can make mistakes because it seems very easy. You've got some metadata, where do you store it? You find your nearest database and you just stuff it in there. But there's actually an art to storing metadata just right. And the art there is just do what data does, which is learn from data practices and apply it to metadata. So what we have ended up going with is a specialized data store approach where we write metadata into a document store or a key value store. Of course, we support all the relational databases, but we also therefore can scale to key value stores for writes. But at the same time, we always emit a metadata change event or a commit log. And this commit log is important because it allows you to then subscribe to changes that are happening in metadata. It's so often that metadata implementations forget about this main thing. When you make changes to metadata, please emit a commit log out. That way, you can then take this commit stream and apply it to the indexes that you want to maintain. For example, if I want to support full text search on my metadata, well, I can just subscribe to the commit log and populate a search index. DataHub comes with Elasticsearch, but you can connect it to whatever your favorite search index is. Similarly, if I want to browse lineage or connect through multiple hops of relationships, maybe I should use a graph index. And so DataHub takes the commit log and applies it to a graph index. We come out of the box with Neo4j, but you could use anything you want. And the list keeps growing. For example, if you want to store operational metadata, we might want to index it in an OLAP store. And that might be another index hanging off of the same commit log. You can take the same commit log and move it off into your data lake so that you can throw your favorite analytics tool against it. This allows you to then index your metadata in the most flexible way possible. So then you can bring it all back together and have a service API that you can actually scale. If you want to make REST queries, we can handle that. If you want to make GraphQL queries, we can handle that. If you want to subscribe to the metadata as a stream of changes, we can handle that too. So this kind of allows us to really scale from even small ecosystems, like literally you can run this on your desktop, or growing to the scale that companies like LinkedIn run at, where we have like upwards of 10 million events per day that are coming into the system and getting enriched. So the end-to-end architecture looks like this for both humans and software, by the way, right? You've got systems up to the left, data or metadata in this case coming in using a combination of push and pull approaches, coming into the DataHub serving tier, which is responsible for storing and indexing all of this metadata in the best way possible. And then off to the right, you've got stream integrations, which are reacting to changes in metadata. So a data set now added a PII annotation. Maybe we need to go in, lock down that data set and make sure that it can only be accessed when someone else comes in and approves the annotation or approves the request based on a business justification. Similarly, you can have API integrations. Goblin, for example, uses exactly this when it connects up to DataHub, uses the compliance metadata that exists in DataHub to drive data lifecycle management. When a data set is deleted, when a member requests their data be deleted, the compliance annotation on the data set is what drives Goblin to go in and clean up data for that member across our whole data ecosystem. So all of those API integrations are possible. And then, of course, you need a human-facing killer app, right? And the first killer app that most companies need and want is the data discovery app. So of course we have that too, and that's the DataHub front end. I'll give you a very quick walkthrough of it. It's a data discovery app, looks and feels like a search application, but you can also explore your data, browse through the different entities in the graph. And once you search for something, hopefully, it's a good search result and you get back a bunch of good results back. Maybe some data sets matched, maybe some people matched, maybe some dashboards matched. And you get some signal on the right around what is popular, what is most likely to be the right answer for the question that you've asked. And that gives you kind of that social signal and allows you to use that power of the graph to understand what is the most likely correct result for the search term that you just typed. In addition, you can dig in deeper and understand where data is coming from and how it got here. So you can look at like lineage. We have both a tabular view as well as a graph view. And that allows you to get a little better sense of how data sets are being processed and consumed and produced. But oftentimes, when we look at how data scientists and data workers try to build trust in a data set that you're planning to use, they're often trying to actually do something with that data set, like maybe write a pipeline that they hope is going to continue working for a long time and not break every day. So the kind of questions that they're asking are actually related to the operational characteristics of the data, not just the lineage or not just the schema of the data or not just about who is using it, but a bit more operational in nature. Things like, is it a time partition data set or a snapshot data set? When was it last generated? How fresh is it? How much time does it typically take to land in the ecosystem? Does it always show up at 7 a.m. or does it sometimes show up at 7 p.m.? Will it break my pipeline? Does it change a lot? Do parts of the data set change? Is someone on call for this data set so that if something breaks, I can go ask them for help? Can I set alerts on it for important changes? Like when a schema changes, do I get notified? Can I get notified? These are common questions that we heard. And to solve those questions, we thought, we could either go and build a whole different tool, or we could just use DataHub for it, because it's kind of perfectly positioned. The stream of changes as they're happening in these individual systems are already being pushed into this common metadata graph. We just need to maybe add a bit more fidelity into it. There's already an end-to-end map for all of the data, so we can non-intrusively observe it. And we've already got the people graph, so we can connect problems with people. And once you can connect problems with people, then you can hope to fix the problems. And so that's kind of one of our ideas around the future of DataHub. And I wanted to share some mocks today with the community around how we're thinking about it and what it might look like. So the future is in the cloud or cloudy with a chance of observability. So you can imagine you come to the dataset detail page and you can see the name, some description, who the owners are, what the tags are. But then you can also see that it's actually a fact data set. Oh, it's partitioned by time, and it's a daily data set. And there's like a nice summary page that gives you the operational health of the data set at a glance. Does it look like it got a clean bill of health? Did all the checks pass? Does the schedule look like the right one? What are the latest stats? Anything off over there? Like, are we having anomalies in the number of rows being produced per day? Things like that. And then you can go in deeper and see things like, row level or data set level stats. How many counts, how many rows are there? How does that change over time? How many columns are there? Does the data set get very wide, or is it about the same width constantly? How many partitions does it have? And things like that. Also, you can have column level statistics that you can dig into. And I think earlier we had Abe talk about great expectations. I think it's a great tool. So if you've got great expectations, running data quality checks for you, wouldn't it be great to see all of those results visualized in the same place where you're also looking at other things about your data set? So imagine, being able to see all of the amazing great expectation results just visualized in the same place where you can see which assertions ran, when did they last run, how many were successful, kind of like unit tests for your data sitting right next to where you have your data set itself. And then finally, we are a metadata log-oriented system. So how can we harness the power of that log even more? Well, we can have an event-oriented view, which shows you, what are the typical lifecycle events on that data set and when did they happen? How many of them were expected and how many of them were unexpected? So you can actually look into them to understand, was this a good change or was it a bad change? So imagine an event-oriented view like this, where you can kind of see pretty much from all the producers of events that are doing things with that data set, whether that is adding a partition to the data set, or that's a compaction job that kicked in and kind of rewrote the data set quietly, or it was a backfill job that came in and restated parts of the data set. Kind of being able to see all of that in line with data quality assertions and everything else. So you can essentially get a sense of, is this data set going through the right events in its life cycle? So that's how we think about kind of the data observability direction for DataHub as a problem space. So I talked about data discovery, talked about data observability, but is that enough? Have we reached DataOps greatness? I think not quite. DataOps is about applying kind of this software deployment, software development practices to data and doing it excellently. So you've got this cycle of build, test, deploy, run, learn, and then come back and build, test, deploy, run. And right now, I would say DataHub is where most companies start, which is first, you've deployed everything, you're running everything, you've got an active system. Let's at least get wide visibility. So let's understand, what are all the data sets? What are all the pipelines? What are their relationships? If we start there, at least we know it's like taking a picture of your data architecture and then being able to put it on a wall and looking at it, but it doesn't change. So at least you can see where everything is at and you get this wide visibility. That itself is hard, but I think we've done pretty well there in terms of where the project is at, all of the integrations it supports. The next thing we're doing is getting towards deep visibility, which is understanding how data is changing over time. So that's the observability track, where we're able to take time into consideration and seeing how schemas are changing, how data sets are changing, how partitions are changing. And you're then able to understand how data is changing over time and react in accordance to that change. But that is still reactive. What you really want to do is have foresight. So where are all the changes happening? In some cases, in a lot of cases, it's in the data, but in many cases, it's also in the code. So when you're making changes to code in your Git CI/CD pipeline, in your Circle CI or in your Travis, can I understand these changes before they happen? And can I prevent the bad ones from happening? So I talked about some of the things we've done with Git integration back at LinkedIn. The DataHub project, I think, is going to evolve to allow for those kind of capabilities in the open source project as well. So the dashes actually represent the amount of work we have done in kind of these three different parts of the life cycle of DataOps. And what we want is over time to have all of these arrows turned solid. So we can integrate into every single aspect of the data lifecycle and do it extremely well. So that was my talk. Thank you for attending. I'm at Acryl and obviously on LinkedIn, so feel free to reach out. The project is at datahubproject.io, and we have a growing Slack community. So please join us and let us know how we can make the project better for everyone. Thank you.